आज इस वीडियो लेक्चर में हम आखान बोर्ड के मे एग्जामिनेशन 2016 क्लास 9 फिज़िक्स का पेपर 1 सॉल्व करेंगे, जिसमें हमारे पास कुछ एमसीक्यूज़ मौजूद हैं रिलेटेड टू आवर 9 चैप्टर्स। सो सबसे पहले चलते हैं हम अपने फर्स्ट क्वेश्चन की तरफ, दैट विल बी फ्रॉम आवर चैप्टर नंबर 1। सो दिस इज़ आवर क्वेश्चन फ्रॉम चैप्टर नंबर 1 and the number of significant figures. We have to identify the number of significant figures in this measurement. So we have 204.600. So, according to the rules of significant figures 2, 4, and 6, these three digits are significant, while the zero lies between two significant, and these two zeros are the ending zeros of a decimal number. It means these two zeros are also significant. So, overall, we have all the digits in this figure as significant. So, the correct answer for this question number 1 is option D, that there are 6 total significant digits in this measurement. Next, we have question number 2, that is also from our chapter number 1, physical quantities and measurement, in which we have to tell us that all the following quantities can be measured by using vernier caliper. We have four physical quantities in the options A, B, C, and D, and we have to identify that which measurement cannot be measured by using vernier caliper. So, vernier caliper can be used to measure the depth, it can be used to measure the length, and vernier calipers can be used to measure the diameter of an object. So, option C we have that cannot be measured by using vernier caliper. So, the option C is the correct answer, that is weight. For the measurement of weight, we use spring balance, or we have a device that is known as Newton balance. So these devices can be used to measure the weight of an object rather than vernier caliper. So this was the answer for question number 2. Let's quickly move to our question number 3 and question number 4. Question number 3 is again from our chapter number 1. And as I've explained in question number 1, so we have another figure, another measurement 0.002016, in which we have to again identify the number of significant figures. So, according to the rules of the significant figures 2, 1, and 6, these three digits are non zero, and these three digits are considered as significant digits. So, what about these four zeros? So, this zero lies between two significant digits. It means the zero is significant, while these zeros are the continuous starting zeros of a decimal number that are considered as non-significant. So overall, we have four significant digits in this measurement. So the correct answer for this question number 3 is option B, that is four significant figures. Next, we have question number 4, and this question number 4 belongs to the chapter number 2, kinematics. So the type of motion in a simple pendulum, we have to identify the type of motion, and we have already studied different types of motion with different examples from our daily life. So we have studied that the motion possessed by a simple pendulum is a vibratory motion, in which body moves to and fro around a fixed point or around a mean position. This type of motion is known as vibratory motion. So, simple pendulum has vibratory motion. The correct option for this question is option B. So, next we have our question number 5 and 6. In question number 5, this question belongs to chapter number 2, kinematics. In a classroom, a student gets up from his desk, walks 4 meters ahead of his friend's desk and collect a book and walk 5 meters back to his own desk. So we have to tell what is the displacement of that student. So one thing that is very important in this question is that that boy starts from his own desk. A student gets up from his desk, so the initial position of that student is his own desk. And the next we have there, he collect the book and come back to his own position. But that student starts from its own position and ends up at his own position. It's mean that the final position and initial position, the final position and initial position of that student is same. So whenever the initial and final positions are same, the displacement of the body is always zero, because the displacement is defined as the shortest distance between 2 points. So if 2 points coincides with each other, if 2 points lies on one another, so the displacement in that case is zero. So the correct option we have is option A. Next, we have question number 6, that is from chapter number 3, Dynamics. If the momentum of the body changes from 20 Newton seconds to 30 Newton second, so Newton second is the unit of momentum. So this is our initial momentum and this is the final momentum. And the time taken by the body for this change in momentum is 5 seconds. So we have to calculate the average force that is acting on that body. So we know that the relation between the force and the momentum, it is defined as the rate of change of momentum is equal to force. So we have to calculate the force. We are given with the momentum. So we have to calculate the change in momentum, that will be equal to 30 minus 20 divided by the time we have is 5 seconds. 30 minus 20 is 10 newtons divided by 5. So we will get the answer to Newton. So the correct option for this question is A, that the force will be equal to 20 newtons. So next we have another question, question number 8. Sorry, question number 7. And this question is again from our chapter number 3, Dynamics. In an elastic collision, which of the following quantity also remain conserved along with momentum? As I've explained earlier in the different past paper questions, that we have two types of collisions between the bodies. We have elastic collision and we have inelastic collision. In those collision, the main difference is the conservation of energy. In elastic collision, kinetic energy of the bodies, or kinetic energy of the whole system and the total momentum of that system remain conserved. While in inelastic collision, only momentum remains conserved while kinetic energy is not conserved. So in this question, we are asked about the which of the quantity is conserved along with the momentum in elastic collision. So the correct answer for this question is option C. So next question, that is question number 8. This is from our chapter number 3, Dynamics. An astronaut is sitting in a spaceship on the Earth, ready to depart on the moon. When the astronaut reaches the moon, what will be the effect on his weight and mass? So, as we know that mass is a universal constant, the mass of the body never changes until and unless the body is not deforming his shape, size, or volume. So the mass of the body always remain constant no matter where the body lies. It is on the surface of Earth or it can move from the surface of the moon. So the only change that occurs is on the weight of the body. We know that weight is equals to mass times gravitational acceleration. So the gravitational acceleration on the surface of the moon is 1.6 meter per second square. That is less than the gravitational acceleration on Earth, that is 10 meter per second square. So when that astronaut moves to the surface of the moon from the Earth, its weight will decrease while mass will remain constant. So the correct option for this question is option C. His weight decreases while his mass remains constant. Let's move to another question, that is question number 9. And in question number 9, this question is from our chapter number 4. And this question number 4, chapter number 4, and this question belongs to turning effect of force. In in four different examples, we have application of torque or turning effect of force, except one. So in the option A, we have a hammer that is used to pull out a nail. So in this example, this will be the fixed point or rotating point, and we will rotate this hammer in this clockwise direction. So our torque is involved in this case. Let's come to the another question, that is the human arm, and it is loading a weight in that direction. So the point of rotation will be at the elbow of this arm. It's mean this examples also involves the rotation or torque. Then we have a spanner that is used to tighten or loosen a nut. So we know that this is the point of rotation in this case. So this example also involves turning effect of force. Then in the option C, we have a Newton balance. And this Newton balance is used to measure the weight of the object. So in this case, there is no application of turning effect of force. So the correct option for this question is option C. Next, we have question number 10, and this question is also from our chapter number 4, Turning Effect of Force. So we are asked with a definition that a body is said to be in dynamic equilibrium. When the body is in dynamic equilibrium, so we know that equilibrium means the net force on that body acting is zero and the acceleration acting on that body is zero. So these conditions are fulfilled in two cases: when the body is at rest or body is moving with constant velocity. In in those two cases, the both conditions of the equilibrium is satisfied. The body at rest is state as static equilibrium, while for dynamic, the body moving with constant velocity has dynamic equilibrium. So in the among those four options, we have the correct option, that is uniform velocity, option B. So a body is said to be in equilibrium when it is moving with uniform velocity. Let's come to the question number 11. This question number 11 is from our chapter number 4, Turning Effect of Force. So in this diagram, two weights W1 and W2 are placed on the rod, whereas W1 is greater than W2. The weight of this first body is greater than the second body for keeping the rod in equilibrium. So right now, this rod is not in equilibrium because the torque in the clockwise direction is greater than the torque in anti-clockwise direction. So for balancing this rod, we have to increase we have to increase the turning effect in the anti-clockwise direction to balance these bodies. And in this given diagram, the clockwise torque is greater than the anti-clockwise torque. For equilibrium, clockwise torque must be equal to anti-clockwise torque. So the first condition we are given that increasing W2. W2, if we increase the W2, the torque in the clockwise direction will increase and the rod cannot be in equilibrium. Or so this option is incorrect. In second option, increase W2 and X remain same. If we increase W2, once again, the turning effect in the clockwise direction will increases while keeping the X same will effect no change in the anti-clockwise torque. It means this option is also incorrect. Next, we have third option that is increasing x. So increasing x will increase the torque in the anti-clockwise direction while W2 will remain same. This means there will be no change in the clockwise direction torque. So increasing the x or increasing the moment arm will increase the turning effect in the anti-clockwise direction. So the correct option for this question number 11 would be this third one. So we have the option B that is correct answer for this question. So next question we have is question number 12 that is from our chapter number 5 gravitation. The weight of an object at the center of the earth. So we know that weight is equals to mg, and where g is the gravitational acceleration, and this gravitational acceleration depends on the distance from the center of the earth. So, as we move away from the center of the earth, the gravitational acceleration decreases. While when we are at the center of the earth, the weight of the body becomes equals to zero. So, the correct option for this question number 12 is option A, that is zero. Next, we have question number 13. This is from chapter number 5. If the radius of the earth decreases and its mass remains the same, so what will be the effect on the acceleration due to gravity? So acceleration due to gravity at a certain height is equal to gme over re square. So in this question, if the radius of the earth decreases, so if we decrease this quantity radius of the earth while g remains constant and mass remains constant, so as we can see that gravitational acceleration is inversely proportional to the radius of the earth. So if we shrink the size of the earth, gravitational acceleration will increases. So we have the correct option, that is option A for the question number 13. Let's move to the question number 14. This question number 14 is also from our chapter number 5 gravitation. The given diagram shows the path followed by a comet when it reaches close to the sun. The shape of this path is elliptical. So this is the correct answer. The comet are the bodies, icy bodies that are revolves around the sun in approximately elliptical path. So we have got our answer, that is option A. Let's come to question number 15 and 16. This question number 15 is from our chapter number 6, work, power, and energy. So the energy possessed by the body due to its motion. So in this question, we are asked with the definition of a type of energy. So the energy possessed by the body due to its motion is known as kinetic energy. If the body is moving, it will have kinetic energy. The more the quantity of motion, more will be the kinetic energy of that body. and kinetic energy's formula is mv square over 2. So greater the velocity, greater will be the motion, and greater will be the kinetic energy of the body. Next, we have question number 16. This is from chapter number 6, Work, Power, and Energy. If the velocity of the body is doubled, then what will be the effect on the kinetic energy of the body? As I've mentioned, that kinetic energy is equals to mass v square over 2. If we double the velocity of the body, this means that m into 2v square over 2. By doubling the velocity, we will get a factor of 4 with the kinetic energy, that is mb square over 2. We take the square of this 2 and the square of this velocity. So in kinetic energy, we have the another factor, that is 4, and this is the same energy as we have started. So by increasing the velocity by 2 times, the kinetic energy of that body will increase to 4 times. So the correct option for this question number 16 is option D. Let's come to question number 17. And in this question, this is from our chapter number 6, Work, Power, and Energy. In this question, the mass of the elevator is 2000 kilograms, and the work done to raise the elevator to a height of 50 meters in 20 seconds. So, we have to find the work done on that body. We know that whenever the body is raised to a certain height, its work done is equal to potential energy, that is mgh, where mass of the elevator is 2000 kilogram, while the gravitational acceleration is 10, and the height raised above the ground level is 50. So we will multiply all these terms, so we will get 1 lakh joules. So the correct option is the option D. Next, we have question number 18, and this question is from chapter number 7, Physical Quantities or Physical Properties of Matters. In this question, if a gas is compressed, then what will be the effect on the pressure of these gas molecules? Whenever we compress or shrink the volume of the gas, the particles present in the gas will move with the greater velocities, and they will strike one another and the wall of that gas container with more frequently. So whenever we compress the gas, the pressure exerted by the gas molecule will increase. So the correct option for question 18 is option A. Let's move to another question, that is question number 19. And in this question, the height of the Tarbela Dam is 143 meters. Assuming that the dam is filled with water of the density 1000 kilograms per meter cube, the value of acceleration due to gravity is 10 meters per second square, and we have to calculate the pressure exerted by the water at the base of the dam. So we know that the pressure exerted by the water is equals to rho gh, where rho is the density of the liquid, g is the gravitational acceleration, while h is the depth under the liquid. So after substituting the values, the density is 1000, gravitational acceleration is 10, and the height is 143. So we will get 143,000 and 0 pascals or Newton. So after converting this into scientific notation, we will get the correct option for this question number 19, that is option C. We will convert this expression into scientific notation. So this will become 1.43 10 raised to the power 6 pascals. And this is our question from chapter number 7, Physical Properties of Matter. Question number 20, once again, chapter number 7, Physical Properties of Matter. And according to Archimedes' principle, the upthrust of the displaced liquid is equal to what? So, in Archimedes' principle, we have studied that whenever an object is completely or partially immersed in a liquid, that object displaces a certain amount of liquid equal to its volume. So, a force is exerted on that body that is equal to the weight of the liquid displaced by that object. Weight of liquid displaced by that object. So the correct option for this question is option C, that is weight. Whenever we insert or immerse an object in a liquid, it will displace the certain amount of liquid equal to the volume of that object. So the amount of liquid displaced was the amount of the liquid displaced and the weight of that liquid, an equal amount of force will be applied on that object, and this force is known as upthrust force. Let's move to another question, that is question number 21. And in this question, we have a normal body temperature of 98.6 degree Fahrenheit. We have to calculate, we have to convert this expression of or value into degree centigrade. So the conversion factor between these two quantity is, so this is the expression for the conversion between degree Celsius and degree Fahrenheit. That Fahrenheit temperature is equals to 1.8 times degree centigrade plus 32. So from this equation, we have made the subject centigrade while the F remains on the other side of the equation. So by substituting the value of Fahrenheit, we will get the answer that is equal to 37 degrees centigrade. So the correct option for this question is option A. And this question is from our chapter number 8, Thermal Properties of Matter. Next, we have question number 22. This is again from our chapter number 8, Thermal Properties of Matter. The amount of heat energy required to change the substance from solid into liquid state at its melting point without any change in temperature. So, this is the definition of a quantity. Let's see which quantity is this. The amount of energy required or amount of energy absorbed by a substance to completely convert from solid into the liquid state. So, conversion from solid to liquid is known as melting, while the energy that is used or that is absorbed by the substance to completely convert from solid to liquid is known as latent heat of fusion. This question number 23 is again from our chapter number 8, Thermal Properties of Matter. When a glass tube is heated at high temperature and immediately immersed in a beaker of cold water, it will crack down, and we have to tell why this glass tube will break down. So, let's say this is our glass tube, and we have heated this glass tube at a very high temperature. So, the temperature of the outer side of the glass and the inner side of the glass is approximately same. So when we put the cold water, when we put the cold water on the outer surface or the inner surface of that glass, so that part of the glass will contract, and the other part of the glass will be expanding due to high temperature, and this transfer of heat will not be easily be traveling through the glass because glass is a thermal insulator. The thermal conductivity through a glass is very low, so this glass will break down very easily. So the correct option is low thermal conductivity of the glass. Next, we have question number 24. And this question number 24 is from our chapter number 9, transfer of heat. All the of the following are the factors on which rate of radiation or the rate of energy transfer through radiation depends. Only one is the exception among those four options, so we have to identify that correct option. So the rate of energy transfer is directly proportional to the surface area. Rate of energy transfer is directly proportional to the surface temperature, and it depends on the color of the surface. The dark surface or dull surfaces emits more energy, more radiation than the shiny white surfaces. So the incorrect factors, that is pressure on the surface. So this is not the factor of the rate of energy transfer. So the correct option for this question is option D. Then we have a last question from our chapter number 9, that is mode of transfer of heat. Metals are the good conductor, or metal are the good thermal conductor, and we have to identify the why metals are the good conductor of heat. So we have studied that metals and non-metal, the main difference between them is metal has got some free electrons that increases the rate of transfer of heat through metals or conductor, while for non-metals the energy transfer is only through the conduction process, and they have got no free electron to increase the conduction process. So the correct option for this question number 25 is option A, that metals are the good conductor of heat because they have free electrons.